Hi, this is part 3 of solving the problem to apply Green's theorem to a plane flow, and we want to show that the rate of flow out of the region S is equal to the integral over S of the divergence of the flow. So from part 2, we had that the area is F, the magnitude of F, times delta S and cosine phi. And this is equal to F, the magnitude of F times 1 times cosine phi times delta S. But what we know that N is the unit normal vector. So we know that the magnitude of N is going to be 1. So we can substitute the magnitude of N for 1. And we're going to have F times magnitude of N cosine phi delta S. And this is just the vector product of the vector field F and this delta S. Now we take the limit as delta S go to 0 and summing over all points of S. So the limit when delta S go to 0 and sum F and delta S, this is equal to the integral from S0 S1 of F and delta S. So for a given curve C that equals Cxy, you know that the unit, the tangent vector is dx over ds dy over ds. And we know that the normal vector that is perpendicular to the tangent, since it's perpendicular to the curve C, is going to be dy over ds negative dx ds. And we know that the dot product of these two is equal to 0. So we're going to substitute this for N. Okay. We're going to have S0, and the integral from S0 to S1 of the vector field, the dot product F and N. I'm going to put here dy over ds negative dx ds. And we know that F is just f of xy g as it was defined at the beginning. So here we're going to have the dot product of these two, and you're going to have f xy g of xy ds. Ds here. Let's erase this. Don't need it for now. gxy product, dot product dy over ds negative dx over ds, and all of this ds here. And we know that the dot product gives us that's f xy times dy over ds plus negative, since we have a minus there, so it's going to be negative g of xy dx over ds. Here we have equals to over the curve C is gonna be this is gonna cancel. I'm gonna have f of xy dy minus g of xy dx. So from here we can have actually that the integral over c, that's negative g of xy dx plus f of xy dy. We have the dx and dy, and we can put that p equals negative g of xy and q equals f of xy, and we can apply the Green's theorem, which says that the integral of curve C, that we have p dx plus q dy equals the double integral over s, the dq over dx minus dp over dy dx dy. We're going to do the same here, and we're going to have that over s, we're going to have the dq over dx minus dp over dy dx dy, and this is going to be the dq is f, so this is going to give us s is going to give us d of f over dx xy minus the d minus a negative is going to give us a plus, so we're going to plus dg over dy of xy d dx dy. So from here we see that we have precisely that this is the integral over s of the divergence of the flow. So this is the proof of the problem. Thank you for watching.